Question 8 is another probability question, this time with a slightly different approach. John plays a game with two sets of cards, set A and set B. Josh takes at random one card from each set. He adds the numbers on the two cards and gets a total score. Complete the table to show all the possible total scores. So there's the card set A, and in set A there's 1, 2, 4, 5 and 7. And there are the set B cards, which consist of 3, 6, 8 and 9. So what this shows, this decision matrix, shows all the different combinations when you add them. So they've done the first few for you. 3 plus 1 would give you 4. 3 and 2 would give you 5. They want you to complete it. Now when you're filling these in, you'll probably notice a pattern as you go. I'm not going to rely on the pattern now, I'm just going to actually add them. 6 and 5 is 11. 6 and 7 is 13. 8 and 1 is 9. Then we've got 10, 12, 13 and 15. 10, 11, 13, 14 and 16. So that's my completed decision matrix. Part B asks, what is the probability that Josh's total score will be greater than 12? Well, in order to find that, because probability is always written as what I'm interested in, so the X, whatever the focus is, divided by the total possible outcomes. So first I'm going to look at how many outcomes are there. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 20. Okay? So there's 20 possible outcomes. How many of them are greater than 12? Well, that's not, because that is 12, so we don't include that. But I want that 13. I want that 13. I want that 15. That 16. That 14. That 13. And there's no more numbers that are greater than 12. So it's 1, 2, 3, 4, 5, 6. So the probability is 6 in 20. And that's a 2-mark question. You get 1 mark for anything out of 20. And you get 2 marks for having it actually correct. The next part is actually quite tricky when you read it, because it sounds complicated, but it's not. Josh's year group are raising money for a sponsored skydive. 60 students, seems important, 60 students are each going to play Josh's card game once. Each student pays 50 pence to play the game. That also seems important. Josh pays £1.50 to any player getting a total of 8. Show that Josh can expect to make a profit of £21 from his game. Now a profit is always the difference between how much it costs you and how much you get in from it. So it's going to cost Josh £1.50 for every player getting an 8. So let's have a look again at our decision matrix and find out just how many options there are for getting 8. I can get an 8 there, and I can get an 8 there, and there's not actually any more options for getting an 8. So I'm going to start by writing that the probability of getting an 8 is 2 in 20. So for every 20 people, 2 of them are expected to get an 8. Now, I want to find 2/20ths of the 60 people playing. It's a calculator paper, so that's fine. If it wasn't a calc paper, I could think, well, if it's 2 in 20, what would it be in 60? Well, I've multiplied that by 3, so I'd multiply that by 3, and it would be 6 in 60. Either way, he can expect 6 people to score an 8. And remember, he pays £1.50 to each person. So I want to find out what 6 lots of £1.50 is, and it's £9. So that's how much it's going to cost Josh. Let's now find out how much money he makes. So 60 students are going to play, so he's going to have 60 lots of, and it's 50 pence to play the game. Now I don't like working in pence, so I'm going to call it 0.50, because that's what money usually looks like when it's in pounds and pence. So I've got 60 lots of 50 pence. That gives me £30. So he's getting £30 income, and it's costing him £9 in payouts. So let's now find his profit, which is £30. Take away that £9 he's going to pay out to the winners, and that's going to leave him with £21. And that's exactly what they wanted in the question. It was one of those questions where they just wanted us to show. So they were giving us the answer. Do anything with those numbers in order to get to 21. It's a 4-mark question, and you get 2 marks, 2 method marks for this step here. So that's 1 mark for showing the examiner that you can identify it's the probability of the 8s we're looking for, and then realising that you have to multiply that by 60. You then get another mark for showing the income, which is £30. And you then get your answer mark for showing the £21 with the supporting calculations. Question 9 is a cumulative frequency question. So Lindsay records the number of miles she drives each day for 120 days. Some information is given in the table below. So 0 to 10 miles for 4 days, between 10 and 20 miles, 18 days, and so on. Complete the cumulative frequency table. So here the first thing you'll notice is that the top table goes from 0 to 10, 10 to 20, 20 to 30. This bottom table goes from 0 to 10, 0 to 20, 0 to 30. So cumulative frequency is illustrated by the fact that you always go from 0, because you're always collecting as you go along. So 0 to 10, 0 to 10. That's the same 4 people that we were looking at above, the same 4 days, sorry. Then here we're looking for how many days she went between 0 and 20 miles. So it's all of these and also those. So 4 plus 18 is 22. Here I'm going up to 30, so I need to add that on. That takes me to 46, and I keep adding the numbers on as I go. That'll be 86, that'll be 110, and that'll be 120. Now part B asks me, on the grid, draw a cumulative frequency graph. So cumulative frequency goes up the side and the distance goes along the bottom. Now cumulative frequency, when you plot the points, you must always plot from the biggest points. Alright, so you're always plotting the biggest distance in this case. So I'm going to plot my first point, which is going to be on 10 miles distance, and it's going to go up to a cumulative frequency of 4. So 10 miles up to 4. Now let's have a quick look at the scale. There's 10 little squares, and it goes up to 20 within those 10 squares, so each square is worth 2. So for 4 I need to go up 2 little squares. So there's my first one. Now I'm going to go 20 to 22. Then I'm going to go 30 to 46. Oh, there's a mistake I've just made there because I'm not concentrating. I thought that was 45 first glance. It's not. If I was drawing in pencil I could rub that out, but it wouldn't be visible on camera. So I'd quickly rub that out and I'd realise that 46 is actually 40 and 3 little ones. So 42, 44, 46. So here is 40 and 86. 82, 4, 6. Here is 50 and 110. 50, 110. And here is 60 and 120. So now I'm going to connect my points with one neat swoop-in line. Cumulative frequency I always think looks like a swan neck. It's going to go through them all and look a little bit like an S-curve. So there's my cumulative frequency graph. Now part C wants me to work out an estimate for the number of days on which Lindsay drives more than 36 miles. So because they've asked me to estimate, it means to use the graph. So where's 36 miles? Let me zoom in. So here's miles. And this actually goes up in ones. So 36 this time is 35. 36. So it goes to there. I'm going to use my ruler. I'm going to go up to my curve. And then I'm going to read across from where that is to find out what the cumulative frequency is. So that for me has come out on 60 and 2 little increments. So it's not 62, it's 64, because I must keep remembering my scale. So the fact that I've got 64 is not the answer to my question. 64 represents the number of days that she travelled 36 miles or less. We wanted the days that she travels more than 36 miles. So we know that she travelled for 120 days. They told us that. I want to take away the 64 days. I've just said that she's travelling less than 36. So that would leave me with 56 days. Now that's my final answer. And this is how the marks are allocated. This will be interesting for you. Here I get 1 mark for showing that I've used the line at 36 miles. However, this is a 2-mark question, and down here I've got the wrong answer. I've done everything correct, but when I looked at the mark scheme, in order to get the accuracy mark, the 2nd mark, I needed my answer to be in the range of 48 to 52. So mine doesn't get a mark because I said 56 days. This is why. When I was drawing my graph, let me zoom in, because at this point I didn't draw my graph through my X. I was sloppy. If I had done that, if I'd have connected that X neatly up to that one, then my green line would have actually gone way up there. And if it had been up there, oops, if it had been up there and I could have read that off where it was, that would actually take me out to what is probably about 69, in which case my answer would have been 120 take away 69. And if I do 120 take away 69, that would bring me to the answer of 51, which would have fallen within my answer range. So please be careful with the accuracy of your graphs.